Okay, what I will talk about right now is something called the nth term test, and this will test for divergence. So this says if I have a series, and if an, if it does not approach 0, then the series diverges. I can also think about this in terms of the contrapositive. If the series converges, then an goes to 0. And the reason for this is that, I'm not going to give you the proof, but the reason intuitively is because we have an area, because this is an area over the real line, we're looking at all the integers, we need the infinite part to be controlled in order for things to not blow up. So here are counterexamples. The one sequence does not go to 0, it blows up. An oscillating sequence, -1 to the nth power. This will also diverge. It won't blow up, but it will also diverge because the partial sums will never settle down. To a number. So they will either be equal to 0 or 1. That's what the partial sums of the series look like. In contrast, here's a convergent series, geometric. So for example, 1/10 to the nth power. This starts at 1, now we're at 1/10, now we're at 1/100th, now we're at 1,000th. And so that you can see that this just goes to 0. So that's a typical example of a convergent series. And of course, anything that oscillates, this will also, this one also converges. This is geometric for -1/10. This will also go to 0. It will just kind of oscillate in the meantime. So there's no problem there. So the nth term test is rather useful, but it very much comes with a caveat. It only tests for divergence, not convergence. This is a very common mistake. Students love to apply the nth term test, but it really is not applicable outside of testing for divergence. So so in other words, if an goes to 0, it is inconclusive. The nth term test is not sensitive enough. It is not nearly sensitive enough to test for convergence. We will need to develop more tests to examine convergent series. So let me do just a few examples of nth term tests. So we're going to look at the following class. So nth term test, we will ask whether the series is divergent or inconclusive. So let's consider the sum from 1 to infinity of 1 plus n, 1/n plus 4. And then we will also consider the sum from 0 to infinity of e to the n divided by e to the n plus n. And we'll also consider the sum from 0 to infinity of 1 over x to the n. And we'll just say x greater than 0. So let's consider each of these problems in turn. So the limit of 1/n plus 4 is 0. We know it's inconclusive. In fact, as we'll show later, the series is divergent. So the nth term test is not sensitive enough. So in this case, the limit of e to the n divided by e to the n plus n is equal to, if I'm going to factor that out, this will be 1 over 1 plus n divided by e to the n. So this will be, in fact, 1, because if you use L'Hopital's rule, then the limit of n over e to the n is equal to 1 over e to the n. That's the derivative of the numerator divided by the derivative of the denominator. So this is, therefore, this is the limit of an. So therefore, by the nth term test, the series e to the n divided by e to the n plus n is divergent. So let me consider this final example here. So the limit of 1 over x to the n, this will be, this is actually the same thing as the limit of 1 over x to the power of n. So this will be equal to 0 if the base is small. So if 1 over x is less than 1. It'll actually be equal to 1 if 1 over x is equal to 1. And it'll be infinity if 1 over x is large or greater than 1. So these are equivalent to saying that x is large, or x equals 1, or x equals, if x is small. So in this case, the sum is inconclusive. In fact, it's geometric, so we know it's convergent. In this case, the sum is divergent. And in this case, the sum is divergent. And the reason, of course, that I went here is because we're looking at whether the limit is 0 or non-zero. And that's what these are the numbers that told you inconclusive or divergent or divergent. Okay, so we'll have to, in order to examine series like 1 over n plus 4, and these inconclusive types of series, we'll need to develop more tests to do this. And so this will be the subject of next video. Thank you for watching.